Okay, let's begin with question number 9. Okay, this paper. Okay, the complex number 1 plus I root 3 is denoted by u. Aha. So they say express u in the form r cos theta I sin theta. That's a polar form. So let's take a closer look at the polar form itself, where r is positive and theta is between the negative pi and pi. That means that's just basically telling that it is between negative 180 degrees to 180 degrees. Okay, that's the meaning. Yeah. So polar form looks something like this. Just going to take a picture from the internet just to help us understand it. Ta-da, looks something like this. So this is a polar form. So x is r cos theta. When z is x plus yi, we can translate it to a polar form like this. Okay, just to show that. And then we return to this. So going to the polar form now. And the reason why theta is the pi and radian and negative pi is because pi radian anti-clockwise, 180 degree in this direction, or negative pi radian is negative 180 degrees. Sorry, the negative didn't come out nicely. Okay, in a clockwise direction. So these are the two meanings, okay, for one complete revolution, which relates or rather agrees with the Argand diagram, which is used for a complex number. The reason why they didn't use XY coordinates is because the Argand diagram makes it unique that the I or the kind of like the y-axis is imaginary. Okay, that is the idea of why they use a new diagram by the name of Argand diagram. Okay, hence otherwise find the modulus and this. Okay, so we know the what the question is asking. So how do we do that? So our complex number is u like that is 1 plus root 3i. So it's a more standard way of writing. Okay, and then this is like the x and this is y. Let's just do a bit of like annotation. This is x is 1 and then the y is root 3. The coefficients, kind of really like a coefficient plus, and then the constants there. So the what is that? The polar form equivalent, sorry. The polar form equivalent for this one, the same complex number u, would be something like this. R and then cos theta. Let me just plate it straight away. R cos theta. You can write it like that, or like this. I prefer writing R cos theta straight away plus I sin theta. We can write sin theta I, but it's very harder without a, what we say, a bracket. So that's what they mean here. So they didn't mention, they just straight away say, but that's the meaning, hidden meaning, where in theory it links to the polar form itself. So let's say we talk about the modulus of R. So generally this the formula is fixed based on the Pythagoras theorem, actually upon a unit circle. With the projection on the, means the extension of the R radius. Let's understand what I'm talking. Okay, let's keep it simple. So modulus R is x squared plus y squared. And then they say, what did they say here? The R is positive, of course, and they're choosing that. And so let's say we're going to talk about compare the coefficients, please. So comparing the coefficient means, okay, let's do the R first, modulus R, then I'll show you how to compare it. So that means, like, for example, R cos theta is actually equals to 1. I used the easier one, the one on the left, which I'm talking about by comparing just to the one without the I. So R cos theta, this whole thing, will be equal to the 1 here without the I. So we can rewrite it as cos theta. As you can see, why wanted to calculate the R first, because it depends on the value of R. So let's do that on the left-hand side, please. So modulus of R will be equal to the square root of 1 square and root 3 square, like that. So simplifying this, we can say that this becomes root of 4. Since R is positive, we can take the R as 2. Okay, it's kind of redundant to write the modulus on a constant, but it's not wrong. Sometimes it's a practice. So it's just R actually. There's no modulus of the R. For a scalar, it's just itself. Okay, anyway. So there we are. So we just substitute just that towards the right, and then let me just type like that. Cos theta is 1 over 2. And theta, we take a value between the positive, because it's on the positive side. And we can choose that theta is, because cos theta is positive first quadrant, and then we take it as 60 degrees. Cos 60 is a special value, but we don't want in degrees. So in radians, this would be equivalent to 180 over 3 or pi over 3 radians. Okay, this is the two values that we need. Okay, so express u in the form means there's one more thing we need to write. The u equals to, pulling it off from this statement. Let's take note. Okay, so 2 cos pi over 3, and then plus I, sorry, 2i, yeah? Did I just miss that? Yeah, I did miss that. There should be a bracket here or an r here. The r multiply the whole thing, sorry about that. And then, so it will become 2, I, let's write the I first. Okay, sorry, sine of pi over 3. So I there. I is a complex number, by the way. Yeah, complex number means the square root of -1. Yeah, this should be the answer. So I accidentally missed that. Sorry. Okay, so now we understand this this meaning, yeah, of the whole thing. Yep. Okay, so now how do you find the modulus of the argument of? Sorry, let me just bring that up. Okay, modulus for the argument of mu square and u square and u cube. So just please remember this: the modulus of u is just r. Okay, the modulus of r likely, in fact, that's where the modulus r comes in. But in this case, a positive 2, so it's 2. So please remember that modulus of 2, modulus of u is 2. That's all we need for the second part. Okay, so I'm just going to clear this, and just write that quickly so you can see the answer for u square. Modulus and argument for this thing. Yeah. Okay, so I put it like this. Let's just write like this: modulus of u is 2. At the same time, the argument of u, so the bracket better. Argument is that fancy way of saying how many degrees is it on a polar coordinate. Okay, using a bit of different words. So the argument is, as we saw earlier, 60 degrees of pi over 3 radians. So whenever you see the pi, I'm not going to write radians anymore because by convention we understand it likewise. So what I'm doing is, so modulus of u square is just a bit of a trick. Just what you need to do is, by using the de Moivre's theorem, if I pronounced it incorrectly, hopefully. So 2 square, this is 4. And then the argument for u square is just, what do we say? 2 times that, 2 times the base number. That means it will become 2 pi over 3 radians. Please take note. So similarly, so you all know already. Oh, so this means that the argument for mu to the power of 3, wait, they keep saying mu, symbol, u to the power of 3 is 2 cube. This is 8. And therefore, this is argument of u cube, which is 3 times the original. Let's start that, pi over 3, or just pi radians. So this is how you do it. It's always going to be n theta. So the de Moivre's theorem, because not really used here in full for this part, but it's the idea is generally like if u is r, okay, let me write this way, let me write fully, yeah. R sine R sine theta R sine theta, and then I put the I, easy to say, and then u to the power of n for a complex number. Found out that by proving using maybe power series, I think, if I'm correct. Okay, I'm not very in touch with calculus all the time because Olympiads don't use calculus, and just mentioning. Okay, so sine theta, sorry, just one is n theta. Ta-da! Taking a lot of things from memory is a little bit harder sometimes. Okay, n theta like that. Yep. So it is the result. So that's why we can multiply the n inside like that. So it greatly simplifies things, isn't it? Because the power of n becomes like n theta. So there we are. So it's the general idea for the part 1. Okay, let's go for the part 2. So show that u is a root of this equation. So how do we show that? So there are 2 ways actually. Because if you there are 2 ways. I'm going to show method 1 and 2 so that we get a bit of flavor on it. So method 1, I'm just going to make it a bit more natural. So the most natural method is to think algebraically. Method 1, a little bit algebraically. So what we do is we know that u is equals to 1 plus root 3i. This is defined already. So they want you to show that u is the root of this equation means. So if z equals to u, so put z equal to u, substitution, and just evaluate the left-hand side of the equation, which is z squared minus 2z plus 4 equals to 0. So how do we show this? Sorry. How do we show this is equal to 0? We cannot put the equal to 0 part. Okay, let's think and see. Want to make this 0 and see. Okay, there's one of the shortcuts is like Actually, there's no real big shortcut on this. So we just substitute the z. That means like it becomes a u. That means we have to do that. Minus 2u plus 4. Aha. And then here, what we do is we substitute. Oh, that means this is 1 plus root 3. The I whole thing square. Minus 2, 1 plus root 3, I, and then plus 4. Okay, when you expand this out, just like a normal algebra, please expand it out. 1 plus 2 root 3i. Aha, root 3, and that. This one becomes, see, on this part, I'm just going to do it here separately so that we get used to the complex number squares, kind of. Okay, root 3 square, I square. And this changes to something like this, isn't it? This is 3, I square is negative 1. So it's kind of weird to write a square as becoming negative, but in complex number, it actually does that. That's why I prefer just straight away just writing minus 3. Aha. And then this part becomes minus 2 when you multiply like that, and this multiply is minus 2 root 3i plus 4. Then it just becomes a matter of algebra. One of the fascinating things in this particular question is that this part cancels off. Da-da-da, it should. Okay, just kidding. Okay, and then this is 1 plus 4, rewriting minus 3 minus 2 just becomes 5 minus 5 or 0. So that means it's a root of an equation. When they say a root, it means a value that zeros the expression, the algebraic expression by itself, which is this part. So it makes it equal to 0. So that's what a root is. Okay, so there we are. That the proof is done. Method 1. Okay, let's go for another method just to diversify things. So let's say we go for that plus. So in method 2, what we're going to do is we're going to look at it like a bit of advanced algebra, a little bit advanced. It's like, because sometimes they'll give special numbers by observing coincidences. It's a bit like competition. Sometimes a lot of things are hidden, like magic. Like it is, you have to kind of figure out the trick. Okay, magic as in tricks, not anything else. And then here, we just rewrite it, please. So when we rewrite it nicely, this is actually, it's just to observe that, what do we say? Like u minus 1 like that. And then we square this. Aha. So if I square the whole thing, and then we realize that this becomes 3i square, and then which is just 3 negative 1. So just playing around with the algebra a bit like that, a bit differently. Instead of substituting it direct, you bring it to the left like that. You remove all the square root, and then it becomes a number. So it becomes easier to deal with. Then when it becomes the left-hand side, say minus 2u plus 1. Yeah. Sorry, the u looks funny. 2u plus 1 equals to minus 3. Then we bring it to the left. Minus 2u plus 4 equals to 0. Isn't that the given equation with just so? U equals to z is the given equation. Aha, that means u is a root. Hence, u is a root. So hence u is a root. So it's a bit simpler sometimes, but to see it is another thing. Be able to say. Okay, now they say sketch an Argand diagram. Argand diagram is the fancy word for kind of like what you do for coordinate geometry in x and y, but now with the y-axis replaced with the imaginary line. Okay, showing the points representing the complex numbers I and u, and then shade the region, which whose points represent every complex number z satisfying both the inequalities. So how do we do this kind of drawing? That means like sketches. So I just want to take a picture from one of the websites I have here. And the reason being, they have drawn this very nicely, this conclusion. Just like when you learn straight lines, you see y equals mx plus c, you know it's a straight line. Like that, just kind of imagine that now we're going to learn new things on the Argand diagram. So it looks something like this. You can pause the video whenever you like, and or take a screen grab and look at it and all that. The website is the nagwa.com, nakwa.com. Okay, it's got a good explanation. We're using only the left part here. They're putting equal sign, equation. So I'm just going to modify and show that it's actually, we're talking about a circle. Okay, I'm not going to talk about the other things because it's not linked to the question. Okay, so just to mention there's a circle. Okay, so if the focus is, that means if I were to write minus modulus z minus I equals to 1, just to comment and change this temporarily to an equal sign, this part, please take note. That means z is the moving variable kind of thing, like the x and y kind of thingy. And it is represents in the Argand diagram, it represents a circle, okay? with the right hand side is the radius. So radius 1, radius size is 1. The modulus makes the radius equals to 1. And with at center is this complex number. This complex number is somehow is a negative I only. That means negative I means 0, negative 1. Sorry, 0, 0, negative I lah. 0, negative, negative 1. Because it's a I already on the Argand diagram. Okay, it's like this. So that means if I want to sketch the Argand diagram now, so what I need to do is I need to just think of a radius 1 and yeah, I'm saying, you all know what I'm saying, huh? Okay, so how do we do that? So how do we do that? So we just draw what we say, a point like that, X and Y, all right. I'm just thinking of how to label the, can't forget the, what we say, the 1, 2, 3, 4 only, right? Yep, it's understood, it's an I lah, on the imaginary line. Okay, so let's draw the sketch of this thing, just a sketch only. So sketch means we don't need to use a, what we say, a graph paper. So let's say we just use something like this. So plot like that. Let me put it a bit higher. 0, negative 1. The center is down there. Ta-da. Okay. And then just going to draw this circle thing. I'm going to use some of these tools here. Okay, but before I use the tool, I need to think of something. Sorry, let me just put a bit of a numbers on the axis so that it'll be more clear. So this is the 0. This is the Argand diagram's imaginary line. Just call it imaginary. Sometimes we do like that. And then this is the kind of like the other coordinate, the axis itself. Okay, so and let's put the negative 1 here. So the center is exactly on this. And then the idea that is a negative 1, that's why I wanted to say this, because you can see that it's going to be like a circle like that. So, and these points are, that means it's going to be exactly there. So I didn't want to draw a circle exactly. So it doesn't contradict the drawing. So it's negative 1 here, dot, dot, dot. From here to here is negative 1, is some kind of tangential thing, right? This is 1, just to show the radius is 1. So you need to show these 4 points. This is negative 2 down here. So where it intersects in this corner kind of thing. Please imagine it's a circle. Okay, so we haven't shaded the region and all that. We get 2 things here. So the left part of the inequality tells me that less or equals to 1. Radius is less or equals to 1. So it's going to be inside the circle. So less or equals to me inside the circle. Inside and on the circle. The on part is on the circle. On this circle, horrible handwriting, sorry, is the radius is 1. That's why it's on the equal sign. On the circle is represented by the equal sign. Inside is denoted by the less, so less than sign. So argument of z is big equals to argument of u. If you notice, argument of u is about, like, let's think of it, 60 degrees. Easier to think than in pi or 3 radians, but you could think in radians here. Okay. Okay, and then so where would the region be? That's a bit tricky part for me. I didn't think of that. So the argument is big equal to 60 means, okay, let's say we use a different color now. Okay, let's say we always start from here, right? The complex number takes big equal to 60 degrees. It starts from where to where? Correct, right? Now what I'm doing. So the complex number and the center is here. I'm trying to think, sorry. 60 degrees is from, let's say, from here like that. And bigger equals 2. So let's say something like to this part. If I'm correct, the region should be just 1. Because this is like something like the 60 degrees here, or pi or 3 radians on the horizontal, right? We take the thing. If I'm correct, yeah, that part I will sketch it, but then it should be just sketch. Yep. Thank you.